3.3, logarithmic functions. And their graphs. So a common log is log base what? 10. Natural log is log base E. All right, and then you had all these lovely properties that you probably can't really read on the screen, but you had them in your notes. So we're going to be using those and this lovely E and L to solve most of these problems. So evaluate the logarithmic expression without using a calculator. So see, unnecessary.
Specifically, don't.
So log base 6 of 1. So this is how they give it to you. A couple of things. We could either recognize this as a property, okay, because log base whatever of 1 is equal to 0. Okay, so we could recognize right away that this is equal to 0. The other thing we could do is log base 6 of 1. Let's say you forgot the properties and you're like, I have no idea. I'm trying to figure out what it's equal to. I have a log. I need exponential to solve it. And so we would say 6 raised to the x is equal to 1. And so what power do I raise anything to give me 1? 0. And so we could then say x is equal to 0. So if you forget the property, this method will work. But when you have a property, we don't even need to use that method to solve it, basically. 4, we've got log base 3 of 81. So again, there's a property for this. Okay, I could run my E and I could have 3 to what power is equal to 81. But my properties tell me that if I have log base B of B to the Y, then it's equal to whatever Y is. So how can I rewrite 81 in terms of 3?
3 to the 4th.
Okay, so I can rewrite this as log base 3 of 3 to the 4th. And then according to property 3, that would mean that this is equal to 4. Now, I'm trying to show you this so you see where the properties are coming from. But again, we could do this as log base 3 of 81 is equal to x. And then have 3 to what power is equal to 81. And you could figure it out that way. Let's see, 6, we have log base 6 of 1 over the 5th root of 36. Virginia's like, I don't like this. Riley's like, I don't like this either. So I'm going to say that ultimately this is going to be equal to x. So you can do 6 to what power is equal to 1 over the 5th root of 36, but that's probably not something that you are super familiar with, so this one might be better to try to rewrite in another manner. So any other ideas on how I could maybe consider rewriting this?
1 over whatever the 5th root of 36.
Maybe we could.
It's the same thing.
I mean, we could take out that 5th root and make it 36 to the 1/5. I mean, it would be the same thing, but at least it wouldn't look as scary.
So 1 over the 5th or the 36 to the 1/5. Is
Yeah.
that what you're saying? Okay. How do I move it to the top? a negative exponent. So I'm going to rewrite it this way first. So log base 6 of 36 raised to the negative 1/5. Because what that did is it allowed me to move it up to the top so that it's something I can potentially work with. Now, this kind of, aside from the exponent, looks like the previous problem that we did. Okay? Where I know that 36 can be rewritten as what?
6 squared.
6 squared. So I'm going to put up here in the numerator of my exponent, I'm going to change that to a 2 and rewrite this as a 6. So that would be log base 6 of 36 to the negative 2/5, or sorry, 6 to the negative 2/5. So then now this would be equal to what?
Negative 2/5.
Negative 2/5. It's just equal to whatever the exponent is.
That's a really convenient property.
It is a really convenient property. Now, just so that you know kind of where it comes from, when we haven't gotten to this section yet in this book, but in, well, I think we did it last year. Did we do logs last year?
A little bit.
A little bit. Okay. So some years I get to it and some years I don't, so I wasn't sure. We have a property that says if you have like a log base, I'm just going to say b of some number raised to a power, we take that power and we throw it out front. Okay, so basically we're taking that negative 2/5 and we're throwing it out front, and log base 6 of 6 would be equal to 1. Okay, because we have a property that says that, and 6 to what power is equal to 6? It would be raised to the first, which is where that comes from. So that's where that comes from, in case you're ever like, I don't understand why like this property works. Like, maybe you don't try to understand why properties work. I don't know. But that's why it works that way. Anyways, that's that. I was going to show you another way to do that problem, but I think this way is easier than what I would show you, so I'd rather just stick with that. All right, 8. Log of 10,000. So what base is on this log? 10. Okay, it's an understood 10. So I've got this as equal to x. So I've got, a couple different ways I can think about this. I can think about this as 10 to the x is equal to 10,000. And I probably need to consider how to rewrite the 10,000, in terms of 10. So 10,000 would be 10 to what power? 10 to the 4th power. So this was the way I was going to show you on the other one. And then if you have the same base, then you can say your exponents are equal. So this would make x equal to 4, which would be the solution to this one. Or you could have, again, done it like we did up here, and you could have had log base 10 of 10 to the 4th is equal to 4 then that way. Either way would work, but I think when it has, the reason I said this one would have been more complicated to do the method I just used for 8 is because we had all this stuff in the denominator. But because this was up here, it was almost easier to write it as this way. But it's kind of just like your preference. If you're like, I'm really liking this, base and the number being the same, then I just have it equal to the power. If you're like, I really like this method, use that method. Like, doesn't matter. Eventually you would get there if you didn't know that 10,000 was 10 to the 4th.
As long as we get the right answer.
How I thought it was 10 squared.
That's 100.
Eventually,
Maybe it's
She did
100
like
squared.
She got there eventually.
Took
How
a
did
second.
you get the understood 10?
Because it's a common log, which is log base 10.
Oh.
If it's not written, it's assumed to be 10.
Okay.
And if it's ln, it's log base e. But we don't ever write it as log base e, like literally ever. We just write it as ln. It's not wrong if you do. We just,
It's
don't
just
do it.
weird.
Yeah, it's just kind of weird once you're used to seeing ln and then all of a sudden somebody writes log base e. It's like, it's really cringy. Like, it doesn't matter, but it's just weird.
I write it on my exam.
Gross.
Virginia's gonna be like, I'm just gonna make her cringe just because I can.
All the AP exams.
Oh gosh, don't do it on the AP exam.
They're gonna come back to you and be like, what did you teach her?
They're gonna be like, no, ma'am, you
Start
cannot teach this class again.
Right now.
Don't get me fired, y'all. All right, 10. Log of 10 to the negative 4. What is this equal to?
Negative 4.
Whoa, that was so fast. What did you just say?
I said, what is this equal to?
I said negative 4.
Why did get there?
It's like,
Because
Okay, it's log base 10. It's a common log. So log base 10 of 10 to the negative 4th is equal to negative 4. Equal to the exponent.
See, I really like that property. So
just threw me
convenient.
off because all those
Everyone just started talking. It was like,
It was like Snoopy and Charlie Brown. Wah, 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 wah.
Apparently, I was the only one who understood it. Am I an adult now?
Charlie Brown adult.
I just got what you were trying to say. I was like, why would you have to be an adult to understand that? I forgot we were
Your
talking
child.
about Charlie Brown.
No.
But all the kids knew what she was saying.
Exactly, which is weird.
Well, they're just different.
I think it was just making fun of teachers because that's what kids have the perception that a teacher sounds like.
What
Probably.
if one day we walked into school and all the teachers were talking like that? And then,
Happened in Miss
like,
Patton's
everyone
class.
else pretended to understand.
I think she done lost it. Y'all be like, yeah, we got it.
Yeah, I got it, totally. What did she say?
Yeah, I'd be like, what?
What? Help? Please.
Be like, your vocab is written in wah, 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 wah. All right, ln of e to the negative 4. Negative 4. Because it's log base e of e to the negative 4.
What was that, Virginia?
I think the next one's going to be Riley's.
Oh, yeah?
Oh, yeah,
What is
see,
it?
I
Is it
like
the
gave
one,
that
the
to
greatest
you.
integer thing? Somehow it's gonna be worked in there.
16. ln of 1. It's a property.
Yes!
Y'all are growing up.
I was gonna give you like 2 more seconds, Riley.
See, we did that. We went from number 10 not knowing what was going on.
I understood what was going on.
Well, you know, it's okay.
It's the sign.
You always know what's going on.
He's
What
just
I
the closest one to me. That's why he just gets it.
Yeah,
Exactly.
it's like you're sharing your like brain power. Like
Exactly.
you just shift it a little bit.
He can see my paper beforehand, you know. All right, 18. ln of 1 over the square root of e to the 7th.
Is that even allowed?
Can we make that
Just like what we did in
Negative
number
seven.
6.
Seven.
negative 7 over 2? Virginia.
Oh.
I
Yeah,
forgot about
so-
the square root.
ln
So
of
we can like make it different
what
things.
is happening? Stop that.
Oh my gosh.
Stop that.
Don't do that.
ln of e to the negative 7 over 2. Okay, because inside the radicals, that means I've got to have a 1/2. It's negative because I need to move it to the top, and then it was raised to the 7th power, so that's where the negative 7 over 2 comes from. So, what is this equal to?
Negative 7 over 2.
Yeah.
Negative 7 over 2.
And I'm convinced he knows all the answers. There's something to do with the glasses. 'Cause you guys both have glasses on.
We both have contacts.
We have contacts. And I never see him without his glasses.
They're embedded. No, they're not.
I mean, I can still see
Now
the
he's
board.
one of us. He's gonna
It's
be
not the best, but I can still
Oh.
see.
Now he's gonna get all the.
It's like in the movies where they're like they give the nerd a makeover. They're like one last thing, and then they take off the glasses.
Princess Diaries.
It's like, well, how are you gonna see?
Pilo's work is I can't do that.
All right, evaluate the expression without using a calculator.
Yay, no calculator.
5 raised to the log base 5 of 8. This is an even better property.
Really?
Is it 8?
It's equal to 8.
Oh my gosh.
It's not the glasses.
I already still think
Okay.
of this.
Well,
So the property is b to the log base b of x is equal to x, basically because you have an exponent raised to a log, those things cancel each other because they're inverses of each other, and that's why it goes away like that, basically.
Less work is less work, man.
This is like the best section of the year. 22. 10 raised to the log of 14.
I'm gonna let you guys take that one.
14.
So proud.
Because it's 10 to the log base 10 understood of 14, which would be 14. All right, Riley's got this one.
Oh yeah,
Yeah, Riley.
24.
Don't mess up.
E
Oh lord.
to the ln of 1/5.
It's so easy,
This is
Riley.
really random. Could be 1/5.
Yep.
Oh my gosh.
Because e to the log base e of 1/5 would be 1/5. All right. I don't know if this was in your notes or not, but we cannot have a 0 or a negative inside of a log. Okay, if it is, it's undefined. So these next problems, for the most part, require a calculator. So
Sorry, Riley.
you can use mine or you can just watch. It doesn't matter.
I gotta remember this way.
Oh, those are next week.
Oh
What?
my gosh. Exams.
Yes, they are next
I
week.
have not once charged this. Well, I
Well,
tried
what's
to,
battery
but I
at?
think I did like, oh, it's at like nothing.
It's running on fumes. Like literally, just
Like,
every time I
that's
open it, it says.
stupid.
what?
Okay, 26.
Die.
Log of 0.908. So you literally just hit the log button that's on the left side of your calculator, then that number, and it's going to give you out an answer.
Negative 0.042. It died right as I said that. The screen just went black.
Now, if you're ever not sure, we can use the E thing to check it. So you could check it by doing 10 raised to the negative 0.042 is equal to, and it's going to give you out. Now, because we rounded, it might give you something slightly off, but it should basically give you 0.908 in case you ever wanted to check it. You don't have to by any means, but that's how you would, or well, it says to check it. I don't care if you check it. I just want you to know that you can. Did you get it?
Yeah.
Okay.
I was just, I guess, fidgeting with the calculator a bit. Sorry.
All right, 28. Log of negative 5.14.
Ew. I think that I put mine in like the A plus the I thing, and it has an I in here.
Oh, there's a negative.
Yeah.
It's undefined because there's a negative, okay? But if you type it in your calculator, it's going to come up and say, like, domain error or something of that sort. Or dimension mismatch or something weird.
Non-real answers.
Yeah, that too.
Maybe I should take this A plus B I thing off.
Probably.
Anyways.
All right, 30. ln of 0.733.
Okay, so that's negative 0.31. Do we want to go farther out?
That's fine.
Okay.
I don't care. I would say 2 or 3 decimal places, depending on what kind of number it gives you. I mainly went out to the third one because that's what she said, but also because there was a 0 at the beginning, so that way we get a little bit more precise or accurate or all of the above. All right, the last thing says to solve the equation by changing it to exponential form. So 34, we've got log of x is equal to 4. So I'm just using the e. So 10 to the 4th is equal to x. So x is equal to 10,000.
Earlier when you said the E, I thought you meant the E button on the calculator.
Oh.
And that's what I was messing with, and I was confused.
All right, 36. Log of x is equal to -3. So we've got, again, the e. 10 to the -3 is equal to x. So what is that?
1 over 10,000.
1,000.
Darn it.
1 over 1,000. Or you could write it as 0.001. Either way would work. So then problems, I'm just going to say 1 through 35 every other odd. Obviously, if you feel like you need more practice than that, you could do every odd, but I think we've got this section under control.
Yeah.
So, test Wednesday on 3-1 to 3-3, just so we can get another test in there. And I think overall this stuff's relatively simple, so we should be okay with that. It'll kind of just be like a longer quiz, basically, but I'll still grade it out of 150. So the problems will be worth, like, significantly more in a sense, but it's not really going to be, yeah.